welcome back to another M&S tutoring video, and today we're going to be going through some of the analytical geometry vocabulary. So if you've watched any of my previous videos, you would know that analytical geometry is very hard on vocabulary, with many confusing words such as transversal, midpoint, bisector, so on and so forth. So I dedicated this video specifically to analytical geometry vocabulary and with specific diagrams to help you understand what the vocabulary really means. So without further ado, let's get started on some of the vocabulary. The first main word used really frequently in analytical geometry is transversal. A transversal, as I explained in many of my previous videos, is a line intersecting two or more lines. So a transversal can easily be defined as something as a line intersecting one or more lines. So say I have line 1 here and I have line 2 here in blue. A transversal is anything, I'll do it in a black again. A transversal is anything that intersects both of these lines. So in this case, this line over here is a transversal. Right? So now moving on. What is a midpoint? A midpoint is a point which divides a line segment in half. This is really self-explanatory, as the midpoint is basically the middle of a line segment. Say for example I have line segment AB over here, right? The midpoint would be a point on the line AB, of course, say M, that divides the line segment AB into two equal parts. So one equal part over here and one equal part over here. Moving on to the next vocabulary, we have a median. A median is a line segment joining a midpoint with a vertex on the opposite side. Now this one is a bit tricky to understand, but using a triangle, you can understand it a lot more clear and more concise. So say for example, I have triangle A, B, and C over here. Triangle A, B, and C. A median, be sure not to confuse it with a midpoint, is basically any line, a line segment joining a midpoint with the vertex on the opposite side. So basically you have to find the midpoint of a line segment or a side of this triangle. Say I found the midpoint of line BC, M over here, and with that midpoint you have to join it to the opposite vertex. So the opposite vertex of line segment BC of course is angle A. So you have to join it with the vertex A. So the line from M to A is a bisector. Moving on to a right bisector. A right bisector, be sure not to confuse this with a median, is a line perpendicular to a line segment that passes through its midpoint. So I'll show you an example again. Using this triangle A, B, and C. A, B, and C. As we have this triangle A, B, and C, we basically get the midpoint of any side on this triangle. Say I got the midpoint of line segment AC and got M over here. The right bisector is basically a line segment that runs perpendicular to the line segment it bisects, which basically means divided into two equal parts. So as M, the midpoint, bisects the line segment AC, it basically goes up on a perpendicular, making both these angles a 90-degree angle. Now, moving on. What is a diagonal? A diagonal is a line segment from one vertex to another. You can use this in various different types of polygons, but I'll choose to express it in, let's say, a parallelogram. If I have a parallelogram over here, right over here, pretty bad parallelogram, but it's okay. A diagonal is basically a line segment from one vertex to another. You have to be sure that the vertex you're going to is the opposite vertex, or the vertex just basically becomes a line segment. So if I have parallelogram A, B, C, and D, a diagonal is basically a line going from A to C, or a line going from B to D. So some things that's really cool about a parallelogram is that a diagonal bisects each other, since the opposite angles are equal in a parallelogram. So when you look at this, the diagonals, as a matter of fact, bisect each other, which means that this over here is the midpoint of both side AC and side BD, which is really cool, as a matter of fact. So that's the entire video, guys. I hope you have a more clear understanding of some of the vocabulary used in analytical geometry, and please feel free to refer to this video as much as you want until you get a clear understanding of the vocabulary, because it's used a lot in analytical geometry. Thanks for watching, guys.